Welcome to the channel. Today we will talk about our sun. Have you ever stopped to think about the power and beauty of the sun, the star that governs our solar system? Imagine if you could witness the most incredible solar storms and understand how they can affect the Earth and our modern technologies. But before that, we need to better understand the dimensions of the sun. The diameter of the sun is about 1.4 million kilometers, making it approximately 109 times larger than Earth. This means you could fit about 1.3 million Earths inside the volume of the sun. The mass of the sun is about 333,000 times the mass of Earth. This means that the sun accounts for more than 99% of the mass of our solar system. The temperature on the surface of the sun reaches about 500 degrees Celsius. In the innermost regions, where the nuclear reactions that generate its energy occur, the temperature can reach millions of degrees Celsius. Although not a dimension of the sun itself, it's worth mentioning that the average distance between the sun and Earth is about 150 million kilometers. This distance, known as the astronomical unit, is often used to measure distances within the solar system. And when it comes to age, our sun is about 4.6 billion years old and is in its main sequence phase, where it converts hydrogen into helium through nuclear fusion in its core. The sun is an immense star vital for life in our solar system. It emits a vast amount of energy in various forms, including light, heat, and radiation. Solar activity, such as solar storms, can have significant impacts on Earth and technologies based on satellites and electronics. Alright, but how could the sun damage electronics here on Earth? The answer to this question has two main pathways: coronal mass ejection, CME, and ionizing radiation. During intense solar storms, large amounts of charged particles are released, along with electromagnetic radiation. If one of these storms is directed towards Earth, it can cause disturbances in Earth's magnetosphere and induce electric currents in communication infrastructures, such as power lines and communication cables, damaging or even rendering sensitive electronic equipment useless. Solar radiation, especially in the form of ultraviolet, UV, and X-rays, can ionize atoms in Earth's orbit. This ionizing radiation can interfere with the operation of satellites and other electronic equipment in orbit. In September 1859, an event occurred when a massive solar storm hit Earth. The storm was caused by a series of solar flares and coronal mass ejections, which released an extraordinary amount of radiation and charged particles towards our planet. This event became known as the Carrington event, and its impact was notable, even occurring at a time when electronic technology was in its early stages. At that time, telegraphs around the world experienced overloads. Several caught fire, and those that were unplugged operated on their own. Is there any way to prevent or mitigate the damage caused by a CME? To mitigate these effects, engineers and space scientists develop protection systems and response protocols to minimize the impact of solar storms on terrestrial and space electronics. This includes constant monitoring of the sun, forecasting solar storms, and developing more robust technologies resistant to space radiation. Additionally, Earth has a powerful magnetic field generated by the movement of liquid iron in the planet's outer core. This field forms a kind of bubble around Earth called the magnetosphere. When a CME hits the magnetosphere, the magnetic field deflects the charged particles around Earth, protecting it from a large part of the harmful effects. In addition to the magnetosphere, Earth also has a weaker internal magnetic field generated by the solid core of the planet. Although less influential than the external magnetic field, it also contributes to protection against solar-charged particles. With all this, we are well protected from major damage. Although if the coronal mass ejection is very intense, we can indeed have damage to our power grid and satellites, as in the events of 1859. There is also the good side of coronal mass ejections, which are auroras. These spectacular visual phenomena are caused by the interaction of solar particles with the Earth's atmosphere and are common at the planet's poles. They are also visible in other parts of the globe when solar interaction is very intense. And if you liked the video, subscribe to the channel. Share it with your friends to support and help the channel grow until the next exploration.